For the last one, we're going to be looking at example 3, which has this data about light intensity, so the distance you are from the light, and the candle power associated with that. So I'm going to go ahead and open that one up, example 3, in a new listen spreadsheet, so what you guys have been doing. And I'm going to go ahead and just use the raw data again. All right, I'm going to say that the distance explains the intensity. Yes, I'm going to go with that. Distance explains the power or intensity. All right, and it looks pretty significantly, almost like a negative exponential, if you will. But I'm going to go ahead and go through the process. The ladder of powers, again, this slide is very beneficial. So we're starting at the raw data. I'm going to see what happens when I square my y values. So I'm going to square the intensity values. So I'm going to go back here. Let's type in square intensity. I'll do square int. Let's go with that. And then I'm going to write, or squint if you will, equals. And I'm going to type in intensity. Hopefully I spelled it right. I'm going to take a look. Oh no, intensity squared. Excellent. There we go. And I'm going to go back to my scatter plot and change this intensity or to square intensity, which is squint. And that pretty much makes it worse. So that one didn't work, which means I'm going to go ahead and X that out. And I'm going to go to the square root of intensity. So I'm going to go back here. We'll call this square root or squint. So square root of intensity. So equals the square root of intensity. Excellent. All right, I'm going to go to my scatter plot and try the square root, see what that looks like. It looks like it's getting closer, but still a pretty significant curve. So now I'm going to go ahead and continue past that to logarithms. All right, so I'm going to go to column E and make this the log of intensity. So log int. So L-O-G-I-N-T, log of intensity. So equals, again, like we did in the last example, I'm just going to use the common logarithm, base 10, so the log of intensity. All right, close it up, hit enter. I guess I don't need that. Here we go. And then now I'm going to go back to my scatter plot and try the log and see what that looks like. Looks a little bit better, but it's still I can still see a curve. So, we could run the regression here and use the model, but I don't think it would be appropriate because I can see a distinct curve in the original scatter plot. So we actually have to proceed further than we've gone before in the first two examples to this power of -1/2, which is the reciprocal square root, all right, which says uncommon, but it can be useful. Let's see if this is going to be useful for us. So we're going to take all of our y values and do the reciprocal of it, so put it in the denominator, but also take the square root of it. So let's just call this, I'm going to call it, go to column F, and try, let's see, recip, so R-E-C, and then square root SQRT of intensity. All right, so I know it's all crazy there, but reciprocal square root of intensity, that's what that is. So let's see if we can do this. So equals, I'm going to put in a fraction, so that's control division side. So now I got a fraction, 1 over, so 1 over the square root of intensity. So 1 over the square. So it's a reciprocal, so 1 over, and it's the square root in the denominator. So 1 over the square root of intensity. Oh no, what happened? No, go back. There we go. Intensity, here we go. I-N-T-E, intensity. And we hit enter. All right, let's see what it looks like now on my scatter plot. Here we go, here it is. Okay, so again, it shouldn't really surprise you that it did that because we did the reciprocal, so we went 1 over all our numbers, and we did the square root, and that looks, sorry, water break. That looks very linear. So I'm going to go ahead and insert a calculator page. So menu, stats, stat calculations, linear regression, a plus bx, I'm still saying distance explains intensity. But again, I'm not using intensity because the raw data didn't work, neither did the square root, or the log, but the reciprocal square root worked. And I'm going to use F1 for that equation. So there we go. So I'm going to type this, or I'm going to write this down. Again, I'm going to round, but I'm not worried about the numbers, just about the process. So when I write the model, I'm going to write 1 over the square root of intensity hat equals my y-intercept of 0.0, how many zeros? 1, 2, 3, 4? 3, 4, and I'm going to round it to 6. I'm just going to confirm it's the right number of zeros. 1, 2, 3, 4, yep. All right, and it's a negative for my y-intercept. So make sure that's a negative. Plus 0.022 times the distance. All right, make sure those numbers are right. 0.022, yes, awesome. So there we go. There is our equation. Oh, there we go. There's our equation for our model, so our regression model. So again, this is, I'm not saying this is right, but this is the most useful, the one that was the most appropriate. Well, okay, if I'm going to say that, I might as well check the residuals. Geez, come on now. Doc, insert data and statistics. We said distance and stat.resid. After I said all this, I hope I see no pattern. Good, looks like no pattern. So it is appropriate after all that talking. And it wants me to find the intensity at 1 foot, 12 feet, and 30 feet. So I'm going to show the work for 1 foot. All right, so that means I'm going to plug in F1 of 1 and then go ahead and show how to do all that, actually get the candle power, the intensity. All right, so let's do that. F1 of 1 foot. Let's go to the calculator page. F1 of 1 foot. So again, if I said F1 of 1, it says 0.021639. But that is not actually what it's going to be, because that is 1 over the square root of the intensity hat is equal to, and then you would write that down, which was 0.021639. 0.021639. 0.021639, but that's not what I want, because I want intensity, not 1 over the square root of it. All right, so we have options here on what you want to do. In my mind, what I do is I move the intensity, which is in the denominator, the square root of it, I should say, to the right side. So now I would move this over there with multiplication. So I have the square root of intensity over there. So I'm going to do 1 divided by that number of 0.021639, which would be equal to the square root of intensity, but then I got to square it to get my actual intensity. So I'm going to do 1 divided by that number. But again, that's just the square root, so I need to square it. And that is my actual intensity, 2,135.57. It doesn't say any units, so I don't know anything about lights. But let's go with lumens. That sounds like a light unit. So 2,135.57. 2,135.57 lumens, if you will. Okay. So again, that's the work to get the the predicted value. Let's try 12 feet and 30 feet. Again, I'm not going to show the work in terms of in writing. I'll just work on it in my calculator. So 12 feet. So F1 of 12. Again, that's not it. That's 1 over the square root of it. So I'm going to do 1 divided by that number, and then I'm going to square it. And that will give me the actual value of 14.761. So 14.761 lumens. We'll just say L for lumens. All right, which kind of makes sense if you look at between 10 and 15, 21 to 9. Yeah, that's right. It's in the mix there. And then 30 feet, F1 of 30 feet. So it would be 1 divided by that number. And then don't forget you need to square it. All right, so 2.36116. 2.36116. 2.36116. All right, lumens. So 30 feet far away. I'm sure lumens is wrong. Again, I don't know anything about lights, but I don't care about that. What I care about is the process. The process. Yes, 1 foot and 30 feet would be extrapolation. So, there's issues there. But the idea is, how do you re-express, and then can you use that re-expressed model, which is here, can you use that model to find predicted values. So we'll have to do some algebra to do this. All right, so that's all 3 examples. You guys can go ahead and start working on quiz A.